Hello everyone. Last class we discussed about the combination of resistors and problems on that combination of resistors. Now in this class what we discuss heating effect of electric current. Why this heating word comes here? We know that we are using daily cell phones, TV and other etc. devices. If you use some continuously for few hours, it will uh, it will get heated. ನೀವೇನಾದ್ರು ಮೊಬೈಲ್ ಏನಾದರೂ ಟಚ್ ಮಾಡಿದ್ರೆ ಬಟ್ ಟಿ ವಿನ ಏನಾದ್ರು ಟಚ್ ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, ಸ್ವಲ್ಪ ಹೀಟ್ ಆಗಿರುತ್ತೆ. ಸೊ ಅದು ಯಾಕೆ ಹೀಟ್ ಆಗುತ್ತೆ ಅಂದರೆ ಡ್ಯೂ ಟು ದಟ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಇನ್ ಎ ಬ್ಯಾಟ್ರಿ, the electrons are flowing from one end to the other end. While traveling one end to the other end, there are number of resistors connected in series. That resistors, some part of energy will get useful, some other part of energy will get dissipated. That's what some part of energy dissipated, that is what called heat energy. Some part of energy ಏನಾಗುತ್ತೆ ವೇಸ್ಟ್ ಆಗುತ್ತಲ್ಲ, ಅದಕ್ಕೆ ಅಂತ ಕರಿತೀವಿ ನಾವು heat energy ಅಂತ. Let us discuss here. This is a circuit. Here this positive, from positive terminal current is flowing. So here resistance it will flow. Some part of energy ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಗೆಟ್ ಯೂಸ್ಫುಲ್ ಆಗುತ್ತೆ, ಸಮ್ ಅದರ್ ಡಿವೈಸಸ್ ಏನಾದ್ರು ರನ್ ಆಗೋಕ್ಕೆ. ಇನ್ನು ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ ವೇಸ್ಟ್ ಆಗುತ್ತೆ. ಅದೇನಂತ ಇಲ್ಲಿ ನೋಡೋಣ ಅಂತ. ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಹಿಯರ್ ಒನ್ ಮೋಡ್ ಇಸ್ ಕಮಿಂಗ್ ಪವರ್. ಪವರ್ ಇಸ್ ವಾಟ್ already we discussed in the last classes, in previous classes, the rate of doing work. Here the rate of consumption of energy, So according to the definition, power is equal to W by T. Here P is power, W is work done, T is time. So we already know that potential difference, that is what V. V is equal to W by Q. So from this, W is equal to V into Q. If we substitute here this equation, P is equal to W by T. So P is equal to, in the place of W, V Q by T. If you write V into Q by T, so what is this? First mathematical form of this chapter, Q by T, what? The rate of flow of electric charge is called current. So that's what I is equal to Q by T. So P is equal to what? V by I. This is what power generated. So one more we have, that how heat is generated according to Joule's law. One more concept, that is what Joule's law. How heat generated in circuit. The heat generation, let us we denote that Hs. The heat generation in circuit is directly proportional to the product of square of the current and resistance and time. This is what Joule's law. So statement according to Joule's law, the heat generation in the circuit is directly proportional product of the square of current resistance and time. It's what Joule's law. That is what Hs is equal to I square into R into T. Other forms of Joule's law, Hs is equal to current, you can write I is equal to what? V by R. So if you write V square by R square into R into T. So if you get R get cancel. So you can write V square by R into T. Or else you can write one more form, V is equal to IR. So this one V into V R into T. From this, if you replace one V IR into IR, that's what V square into R into T. So if you replace, the fine same answer will come. If you replace resistance, what will come? Resistance is equal to V by I. From this, I square is equal to R square into T. I square V by I into T. These are different formulas of heat generation. So from this we can write I into. So these are the different formulas for heat generation. Now we will solve one question. You will understand. Hundred joule of heat. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the. Find the potential difference. Find the potential difference across the resistors. Across the resistors. So given data. Here heat energy is given. That is what Hs is equal to 100 joule. Resistance is equal to 4 ohm. Then what they give? They are asking time is equal to each second, 1 second. Then they are asking V. So to calculate V, we have one more formula, that is what Ohm's law. V is equal to IR. Here one more unknown, I also you have to calculate. So we have heat energy formula. Hs is equal to what? I square into R into T. From this we can calculate current. After substituting this current value in this formula, we will get potential difference. 100 joule into I square we don't know. R is 4 into 1 second. 4 into 1 4. If we come this one, it will become 100 by 4 is equal to I square. 2 is a 50 is a 2 is a 25 is a. So it become I square is equal to 25. If we send this square sides, it becomes square root. Square root of 25 is plus or minus 5. Here for time we will take plus only, plus 5 second. I is equal to what? 5 second. So according to Ohm's law, V is equal to IR. Here time is 5 second. Resistance is 4 ohm. So 20 volt. So voltage generation is 20 volt. This is about a heating effect. What is the practical application of heating effect in electric current? Practical application. Practical application of heating effect. So due to the heat generation, we have due to this concept, for some devices we will convert that the main source only generating heat. That like devices car, for example heater. ಇಲ್ಲೇನು ಮಾಡ್ತೀವಿ ನಾವು, ಅಲ್ಲಿ ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ಎನರ್ಜಿ ಮಾತ್ರ ಏನಾಗ್ತಿತ್ತು, ಹೀಟ್ ಎನರ್ಜಿ ಡಿಸ್ಪೇಟ್ ಆಗಿದೆ. ಇಲ್ಲೇನು ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ ಸಮ್ ಪ್ರಾಕ್ಟಿಕಲ್ಲಿ ಹೀಟ್ ಎನರ್ಜಿನ ಜನರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಮೇನ್ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲಿ. ಅದರ ಥರ ಯಾವ ಹೀಟರ್, ಟೋಸ್ಟರ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಓವೆನ್, ಗೀಸರ್, ಇವೆಲ್ಲ ಪ್ರಾಕ್ಟಿಕಲ್ ಅಪ್ಲಿಕೇಶನ್. ಸೆಕೆಂಡ್ ಪಾರ್ಟ್, ಸೊ ವಾಟ್ ವಿ ಯೂಸಿಂಗ್ ಬಲ್ಬ್. In bulb, the filament is heated. The filament is heated to extreme temperature. So due to this, light energy will come. And one more practical application, the electric fuse. We will discuss this in next chapter. Some introduction. Electric fuse. ಇಲ್ಲಿ electric fuse ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, sometimes some variation in the current. Sometimes ಏನಾಗುತ್ತಾ, due to that overloading or short circuit, what will happen, the current in the wire circuit will become less or more. Due to that less or more, our devices, what are the devices connecting to that power supply, they will get damaged. To avoid this, we use electric fuse. ಇಲ್ಲಿ electric fuse ಏನಾಗುತ್ತಾ, electric fuse generally they have less melting point. ಜನರಲಿ ಲೆಸ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಯಾವಾಗ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತಾ, ಡ್ಯೂ ಟು ದಟ್ ಹೀಟಿಂಗ್ ಎಫೆಕ್ಟ್, ಅದೇನಾಗುತ್ತಾ, ಮೆಲ್ಟ್ ಆಗಿ ಅದೇನು ಬ್ರೇಕ್, ಸರ್ಕ್ಯೂಟ್ ಏನು ಕ್ಲೋಸ್ ಮಾಡಿರುತ್ತಲ್ಲ, ಸರ್ಕ್ಯೂಟ್ ಏನು ಮಾಡಿಬಿಡುತ್ತೆ, ಓಪನ್ ಮಾಡುತ್ತೆ. ಅದು ಓಪನ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ನೆಕ್ಸ್ಟ್ ಸಪ್ಲೈ ಆಗಲ್ಲ. ಸೊ ಇಲ್ಲಿಂದ ಏನು ಮಾಡ್ಬೋದು, ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿವೈಸ್ಗಳಿಗೆ ಸೇವ್ ಮಾಡ್ಬೋದು. ಡ್ಯೂ ಟು ದ ಲೋ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ದಿಸ್, melting point of fuse will get damage early. Circuit will open. So power supply current will not flow. will not flow. So from this we can save other devices. So last topic of this chapter, that is what? Power. Already we derived the definition. What is power? The rate of doing work. The rate of doing work. So what is electric power? The rate of consumption of energy. What is electric power? The rate of consumption of energy. The rate of consumption of energy. So from this we already derived formula. What is that formula? P is equal to V into I. So what are the different formulas? So we have Ohm's law. V is equal to I into R. If you replace V by IR, it will become P is equal to I into R into I. So from this P is equal to I square into R. This is also one of the four formula. Then P is equal to VI. So we have Ohm's law. P is equal to what? V is equal to what? V is equal to IR. From this I is equal to V by R. So it becomes P is equal to V. I is equal to what? V by R. So V is V into V square by R. This is one of formula. Then P is equal to VI. From Ohm's law, V is equal to IR. So from this R is equal to what? V by I. So if you substitute in this formula, P is equal to here resistance not have. So from this it become, these are the formulas. If they give a resistance and voltage, this formula we can apply. If they give current and voltage, directly you can always apply. If they give current and resistance, this formula you can use. P is equal to V square by R. So what is the SI unit of power is? SI unit of power is watt. So watt, what is 1 watt? P is equal to VI. So what is 1 watt? 1 watt is equal to 1 volt into 1 ampere. Here one more conversion we have, important conversion. What is that? How to convert 1 watt, 1 kilowatt hour in terms of joules. So we already know sometimes some shortcuts you have to shortcuts, not some short forms. Kilo is equal to how much? Kilo means 10 to the power 3. Milli means what? 10 to the power minus 3. Micro means what? 10 to the power minus 6. Mega means 10 to the power plus 6. Nano means 10 to the power minus 9. Deca means 10 to the power 10. Okay, here 1 kilowatt hours. You are what you are in terms of you want joules. So kilo means what? 1000. Watt. So here from that watt So watt. What is power? Power unit. Power unit is what? Watt. So power we can write work done by time. So what is the SI unit of work done? Joule. Second. So watt also we can write as joule per second. So here watt we can write joule per second. Here we want joule. This one you have to convert into seconds. So 1 hour is equal to how much? 60 minutes into 60 seconds. So that is what? 3600 seconds. So it becomes 3600 seconds. This one get cancelled. If you multiply it become 36 ones are 36, 3020, 5 zeros. So this one you have to write in point in decimal. 1 2 3 4 5 6. 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. This is important. They will ask for 1 marks. So we will solve one more problem and wind up this. Question. An electric bulb is connected to a 220 volt generator. The current is 0.5 ampere, 50 ampere. What is the power of the bulb? What is the power of the bulb? So here given data, voltage is given 220 volt, current is given 0.50 ampere. What they are asking? They are asking power. Direct formula. You can expect this like questions. Power is equal to what? V into I. V 220 into 0.5. 0.5 you can write as 1 by 2. So 220 divided by into 1.2. 1 So power will come. Power is equal to 110 watt. That's all for today's class. You have any questions? Next class I will solve all exercise questions from textbook. Please share and like. Thank you all.